Hello everyone. Today we are going to understand eventual consistency versus strong consistency. So in distributed systems, you would come across these two terms very often. So let's understand this. What is strong consistency? Say I have three nodes or one write node, and there could be two replicas. Say a write happens. So the write node will first get the update or new insert, whatever you could say. Then the other two replicas will get the replicated data from the main node. That's how the replication works. Now, when we say strong consistency, it means if I read from any of the replica or nodes, basically, it should return the same data. That's the strong consistency. Each and every node has the same data. So here, when I write x equals to 1 at time t0, so at whatever time, say like time t1, if I read, then the data should be x equals to 1. So that's strong consistency. So data is same across all the nodes. So this is strong consistency. This is required in your banking transactions. Let's suppose you do a transaction from one ATM and then you check your balance, and both should be same. And what is eventual consistency? It is basically, we are saying the replicated nodes may return stale data immediately, that is after the write. They write when we do x equals to 1 here at time t0, and this node basically it's a write node, so it is x equals to 1. The other nodes are still reflecting the old value. So when someone reads this data, they will get x equals to 0. So that's the stale data that you might get, but eventually the replication will occur and then you will get the same value. But the read operation will continue. We don't stop the read operations. And in that case, we might get stale. And that is what we are saying eventual consistency. That is all the nodes will eventually become consistent. And when we say strong consistent, every read should return the same data or the most recent value. That's the difference. So if you see, what do we get from eventual consistency? We get the high availability. Say suppose there is a network failure. Say replica 3 is not in the network. There is a communication issue. It's down. Now your read operations will still continue. That is, we are saying it is highly available. But in case of strong consistency, it is about high accuracy. So if there is a network partition which occurs, then you will forego the availability. You will wait once all your nodes are in sync or connected, only then you would return the data. That's high accuracy. And it is highly scalable as well. You can keep on writing. Scalability is here also. It's just that you need the correct data or basically same data across all the nodes. And obviously there will be low latency rates and it will tolerate network partitions. So this is about the eventual consistency and strong consistency. There are two concepts basically. If you with strong consistency, like we have seen in all the RDBMS ACID properties, right? Atomicity, consistency, isolation, and durability. So either the transaction completes or it fails. There is no partial thing. And data is always in a valid state. When we say x equals to 1, it is x equals to 1. And transactions don't interfere. So basically, if there are parallel transactions going on, they work in isolation. Durability. So once you give that commit is successful, that means data is persisted. After that particular statement, even if your database goes down and if you bring it up, you will get the same value, the durability factor. And in case of NoSQL databases, you will get this base for eventual consistency. It will be highly available, that is basically available. Soft state may change basically, like you see here, right? X equals to 1, X equals to, the state is changing, and eventually it will be consistent if there are no more updates. So that's the definition of base. You'd come across this in the Apache Cassandra, DynamoDB, etc. And related to these is cap theorem. So when we say strong consistency, in case of a network partition, you will always get CP, that is consistency and partition tolerance. And in case of eventual consistency, you won't get the C, you will only get availability and the partition tolerance, that is AP. See how these are related. That's all about the eventual consistency or strong consistency. Thank you so much.